Hey guys, Kodak Arnis here, and today we've got a slightly different one. I'm going to want to talk to one of these, Python, or more correctly, I want to be able to send this thing commands over the serial port and get it to respond to commands and send me back results and stuff like that. So, standard procedure here. Let's plug the Nano into the computer. Right, so now we're here. Let's just upload a blank sketch to make sure that the Nano is blanked and we actually have connectivity, which we do. Right, let's start off by saying serial up again, 9600. So we got serial system set up, standard built in. Now, serial has a nice thing which is serial dot available. So they'll say, do we have anything to read? Well, let's read out. That'll read us character. And you go, brilliant. What do you want to do with it? We need to put it somewhere because let's just say I want to send the command ready, question mark. This needs to be able to pick up the characters and say, oh, okay, he's now sent us a string ready. So we need to put them somewhere. So let's just create ourselves a buffer and let's make that buffer size. So let's define that at the top, define buffer size 512. Well, but realistically, what we have is buffer size of 1200 plus paranoia, P-A-R-A-N-O-I-A, P-A-R-A-N-O-I. So, and what extra is let's just say 12 bytes. Now, people are going to say, why do we add this extra bit? Off by one problem's hard. Sometime you're going to say, actually, I'm meaning index 0 when you actually want index +1 and vice versa. So realistically, throw yourself a bit of extra stuff in there to handle coding errors. So let's just make that 12 and say, yeah, buffer size 512, but realistically we only ever want to read 500 characters. And the current index, so let's say int is current index equals 0. So that is what we need. What we'll do here is we'll go buffer current index equals C, and then we'll just go current index +1. So that'll add 1 to it. And then you go if current index is greater than 500, because someone sent us absolutely massive chunk of data we don't want, current index equals 0. So we'll just overwrite the buffer. We'll just keep going round and around the buffer, and in effect, we'll just become a circular buffer if someone sends us megabytes. And what we'll do is at the end of this loop, we'll go, okay, every time we read a character, so we'll do println, and we'll print out the buffer. Now, one thing to remember is that a buffer in a string in C has to end in a null character or 0. So basically what you do now is current index equals null, 0. So what that means is we stick the current, let's say we're a completely empty buffer, we get a first character, so the first character becomes a C, and the second character now becomes null, and as far as serial returners, we have C, null. Then we add another character, null just moves along. So as we're sending characters to it, it should just send them straight back to us as we type. So let's try that. Upload. Monitor. So if we go A, enter. We've got an A, and then we've got the enter character. We do A, B, C, D, F, enter. You can see it building up. So it goes A, got an A back, got a B, A, B, C, A, B, C, D. Why is it printing us a single character back all the time? Interesting. I don't know what's doing that. Ah, oh, because it's a character return, isn't it? So it's a and then a character return. Let's just re-upload to blank the buffer on the machine. Confused myself there for a minute. Easily done at this time of day, but never mind. So if we go A, B, C, D, E, you'll see we get an A, then a B, then C, then D, then E, then the character return. So this is character. No line ending. There we go. So if I just send a space, we now get the space at the start, followed by A, B, C, D, E. Sorry, A, B, C, D with a space at the end of character return. There is a space there. So anyway, that will then run through, pull in the characters. We don't need to do that because that's just echo. So let's move this up here, called void update buffer. We come in here and go each time around the loop, we'll do update buffer. Now, one thing we want to say now is, have we had a command? Or have we started a command? And my syntax for commands, which I like to use, is something like that. So it starts with a angle bracket ID, then end angle bracket. So that basically becomes my start character and my end character. So what we can come up here is, well, what we're interested in is full start character detected, false, full end character detected was false. So we come in here and we read the character. But if we start with an empty buffer, we don't really care what characters you send me until we see the start character. So what I want to say is, if start character detected equals false, so we haven't started detecting a string yet, and if C is the angle character, then start character detected is now true. So what I've gone here is gone, well, okay, so if we've started a character, and we'll have one up here, yeah, that's fine. So we've started a character to we haven't started the string, we've got the start character, we've started a string. Then we come down here and go, if end character detected is false, if C equals end character, then end character detected equals true. But realistically, we don't care about that if we haven't already detected the start character. So what we want is, if we've started the string and we haven't ended it, and we now have ended it, we're back to true. If that makes sense. So if you think about it, I'll flick back to my pad so I can explain it. Nope, come on, let me press that button. Fine. So if you think about it, we have the buffer sitting here. It's empty. Let's say it's got 4 or 5 strings in it. We don't really worry about putting anything into here until we've detected that. Because realistically, if you send me A, B, C, that, ID, that's irrelevant. I don't care about that. So what we can do is we only start putting stuff into the buffer when we've detected one of them, and we only, once we've detected one of those, the command should be stored in our buffer. So if we put back the code, what we have here is, so have we started the string? No. But we've detected the first character. Brilliant. Are we in a string? Yes. Have we picked up the end of the string? No. We have now. And realistically, this, we only want to do this if start character is detected. Have we actually got a string? So this will handle us in case we turn the Arduino on halfway through a set of command strings. It'll just ignore something until it picks up a start character and then start accumulating the information. So, well, we actually know that if we have a start character detected and we have an end character detected, well, what does that mean? We have a command. Yeah, we know that the buffer has a single command in it. So if we do, let's create a new thing, so process command. Now once you finish processing the command, well, why don't we just set everything back to how it was, and then index current equals 0. So that resets the buffer. So it resets the processing back to saying we don't have any command, it's blank. So we now need to void process command. So void process command. So this will be called whenever we have a command. So to start off with, let's just print command detected. And then let's output the command that is detected. So serial print line buffer. So let's upload that and see if it works. So if we clear that, let's get rid of the timestamp. Now I go Bob ID. So yes, ignore the Bob at the start and just an ID. Let's see, command spaces. Yep. And if we do that, yep. So it's picking up the commands one at a time. So then we just want to say something like, no, let's comment out this. We know that's working. And go if string compare ID to buffer equals 0. So basically, does the buffer contain the string ID? If it does, 0.println. And we're going to use the same protocol on the way back. Arduino. So if I run that now, and go clear that. So if I send it the command Bob, it's going to go, nah, nothing. If I send it ID, it sends back the string Arduino. That's cool. So we now know at 9600 baud, we can talk and send it the string ID, and it'll send us back the string Arduino. So what we need to do is we need to close the serial monitor, because I don't want anything talking to this. I don't want the IDE talking to it, because now I want to switch to, right, here's PyCharm, my IDE, so let's get it talking to the Arduino. So we need to send it that string. So what do we need to do? Well, first off, let's create a connection. So connection equals, now I'm using the PySerial library here. Serial.serial, whoops. I don't want it on COM3 because I'm running on Windows. I want a baud rate of 9600. Whoa, 9600, and let's have a timeout of 5 seconds. So that'll connect us to the serial port. Now, in the past, I have noticed that there needs to be a little sleep here. No, Import, oops, import sleep runtime. That's where it comes from, is it? Oh, runtime import sleep. I knew it was one way or another. So yeah, I found I had to sleep for about just under 2 seconds for the comms to settle down and get initialized. I think it's a Windows thing, might be a both. Actually, no, I've seen it on my Raspberry Pi. So I don't know why, for some reason this library needs about a second just to settle itself down. But anyway, connection.send. So write, isn't it? I want to write ID. Now, that B there on the string means treat that as a binary string, or actually very simple characters. It doesn't use any UTF, because I'm not using UTF-8 characters or anything. And so we write that out. We then flush the connection to make sure that it has actually been fully sent. And then now, because if you remember when we were looking at the Arduino before, the actual code, you can see there that it says on it, where is it? Print line. So it'll return us a carriage return line feed at the end of the method. Sorry, at the end of the message back. So once we get back to the IDE, read line will read us a line of text. But the problem is that line of text is in a binary format. It's in the same way as this one is, a basic format. So we need to decode it. So we need to say, well, actually, we need to decode that to a string, and then let's just print it out. And we need to encode that one. It doesn't need to be a binary string. It's just that, but we need to encode it back to ASCII. That's the one. Coding is ASCII. And let's just put errors to make sure that we don't put any dodgy characters in. What's this one saying? Oh, sorry, I'll put it into string like that. How's that? That's better, that makes more sense. Yeah, let's just run that, see what happens. Save that, run it. There we go. So we're sending the message, so let's just put some text in here, some debugging lines. So we're sending command and reading response. Sending a command, read a response. Now, if we send the command ID Bob, we shouldn't get anything back. This should just hang, waiting for a read. Yeah, it hasn't come back because, you know, the little nano at the other end's going, don't know what ID Bob is. Nah, don't know that one. So, yep, doesn't know what to do, so just sits there going, I don't know what to do. If we stop that, and let's change that basically, let's just send multiple ID. Should expect to see 3 commands here, so 3 responses. I'm only reading 1 line. 1, 2, 3, 4. That's just up to 5 responses. It'll hang on the first one, whereas, well, not hang. It'll sit there waiting for the response. There you go. 1, 2, 3, and it's now waiting for the rest. So it'll just sit there spinning, waiting. So yeah. So that is how you get Python, very simply, talking to a Nano, which is sitting here on my workbench. So yeah, hope you found that interesting. That's how you can get Python to talk serial to your Nano, send it commands, and the idea is that this thing will then be able to turn on the relays we've been doing previously, reading flow meters, reading temperatures. So hopefully by now, if you've been following on for this tutorial series, you may have a reasonable idea what I'm getting up to, or at least starting to get to the picture. So hopefully you've learned something. Hopefully you found that enjoyable. Like and subscribe, and I'll catch you guys later. Bye.